A viewer of this channel sent me a question, which he later deleted, that said more or less, where can I find good programming problems for me to practice on? Good question, and it's quite related to another video I did recently on how to become a great problem solver. Welcome to Frank Stajano Explains. I am a full professor in the Department of the Science and Technology of Computers at the University of Cambridge. Among other things, I teach algorithms to our first-year undergraduates. I help them to learn how to solve complex programming problems and how to become better programmers. So I think this is a very good question because it shows the right attitude, namely looking for problems to solve. That's one of the best ways of becoming a better programmer, practicing. If the question is how to find good problems, then we have to define what good actually means in this context. And this is a pedagogically crucial point. You become good at solving problems, any kind of problems, including programming problems, by solving plenty of problems. The more problems you find a solution to by yourself, and I emphasize by yourself, then the better you become at solving new problems. Practice, practice, practice. Korogi sensei, the sensei of my first kendo sensei, once gave me this tenuguri with his calligraphy of the kendo proverb Hyakuren Jitoku, which could translate as I do it 100 times and I get the hang of it. If you want to become good, you have to practice. There's no shortcut. But it's actually a bit more subtle than that. You must practice, and it must be challenging. You must practice something you're not quite able to do just yet. But at the same time, it must be within your reach, provided you stretch yourself a bit. If you practice something that's totally out of your league, totally beyond what you can actually do, if you practice and fail, practice and fail, practice and fail 100 times, a million times, you don't in fact become any good. You just become angry and frustrated and depressed, and you eventually give up. If you fail all the time, it's no good. But if you win all the time, it's no good either. It means it's too easy. You're not challenging yourself, and you're not learning very much. You're just refreshing stuff you already know how to do. You're not becoming any better. So if you want to improve, you must practice and persevere, but on problems that are at the right level for you, which means somewhat harder than what you can already do well. And this applies to kendo, it applies to programming, it applies to learning a musical instrument or a sport or natural language, it applies to anything. From a pedagogical viewpoint, and remember, I'm a professional educator at one of the best universities in the world, and I have chosen this career path, abandoning a more lucrative one in industry, because I really enjoy teaching and helping people develop their talents. So from a pedagogical viewpoint, I was saying, a good problem is therefore a very subjective thing. A good problem for you is not the same as a good problem for me or for a third person. A good problem for you is a problem that is tailored to your level and stretches you a little bit further than where you are. It's going to be difficult, it will give you joy when you finally solve it, but it's not so difficult that you can never solve it. And a really good problem is one where after you finally manage to solve it, you discover there was a hidden new challenge you could tackle after that one, now that you've figured out the first difficult bit. And perhaps there's yet another one hidden in there after that. And these good problems are pretty difficult and time-consuming to build. They don't occur naturally. Someone has to manufacture them, and they are precious, and they are not easy to find. We give you these as little treasures when we do a supervision here in Cambridge. Of course, there are also plenty of problems that just occur naturally. They were not invented by someone for the purpose of letting you practice on solving a problem. And they are possibly much more practical and interesting than these artificially constructed ones. But they are not of calibrated difficulty. They are not made for guiding you towards having that enlightening light bulb moment where you finally get it. They just exist, okay? And until someone solves them, then nobody knows for sure in advance if they're going to be easy or hard, and if they're hard, how hard. Of course, someone skilled in the art is going to have a good guess, and if the problem is similar to something that has been solved before, then this will allow that competent person to give a qualified estimate of a sensible method to solve it, and of how difficult and how laborious it's going to be to solve it. But if it's a problem that nobody has ever solved before, then a problem that basically nobody knows how to solve, then nobody really knows how hard it's going to be until someone finally tries and succeeds. And that kind of problem is called research. So there are didactic problems purposefully designed to teach you something, and real-world problems, which nobody designed, problems that just are, and they are waiting for someone to solve them. And if nobody's been able to solve them before until now, then they are research problems. And while it's true that you will inevitably, as a side effect, learn a lot of unforeseen stuff by solving a research problem, they are not the kind of problem you should start with when your purpose is simply to learn a specific topic, a specific area. For that, you're actually much better off solving problems that were specifically designed to help you learn or perhaps by solving real-world problems that have been already solved by someone and classified by difficulty and by the lessons they teach, which of course means they are no longer research problems. They're real-world problems that are used in the context of teaching. So what I was saying is that the better designed problems take a lot of work to design, and they should be treated as a precious resource because of their scarcity. Each such problem can give you one special light bulb moment or several when you solve it by yourself, but you can only solve it as a new problem once. And after that, it's no longer a new problem for you. It's like going to the cinema to watch a great movie. You can only watch the movie without knowing the ending once. Sometimes my students are offered one of these precious, carefully crafted problems. Perhaps it was a past exam question. And they try to solve it. They think about it for a while. They think they have an answer. They're not sure if it's quite right. They're not sure if they would, get full marks for it. And so they ask, what's the actual answer? They want to see the official solution. They want to see if the idea they came up with would give them the maximum marks. And the fact that they even ask suggests that they haven't really got the full light bulb moment. If they really had it, they would know without a shadow of a doubt what the best answer is. And it's precisely to let you live that light bulb moment, live and enjoy it, that the educator crafted that particular problem. But if you look at the solution without having first fully solved the problem yourself, you'll never be able to solve the problem by yourself later. You will have spoiled it forever. You might think you've now acquired a new method by reading the solution that will allow you to solve another similar problem later if it comes up in another exam question. But you haven't. There's a world of difference between having been told how to do stuff and having discovered how to do stuff. And the first is easily forgotten, but the second one becomes part of you. And this is a fundamental pedagogical principle backed even by neuroscience. The stuff you learn best is the stuff you find hard, but eventually discover by yourself. And the great teacher is the one who puts you in the right condition, with the right preparation and the right hints, with something just as hard as needed to make this discovered by yourself. Looking at the solutions kills this process. The flesh is weak, as they say, but resist the temptation if you want to learn. So let's recap. You learn best by putting the theory into practice. And the most effective learning experience is the one where, instead of just being told what to do, you discover the solution by yourself. Good problems for learning are those that are designed and crafted to lead you towards discovering the solution by yourself. And they are precious and rare, and they should not be spoiled by peeking at the solution. Struggling to find the solution by yourself, conquering the solution through your own efforts, is a crucial part of your learning experience. Good problems for you are those whose difficulty is tailored to your level. And it's problems that stretch you a bit, that are a bit harder than what you can already do. And where do you find these problems? Well, if you have the luxury of being assisted by an individual mentor, as you do here in Cambridge when you are taught by world-class experts and then you enjoy the benefit of personalized supervisions in the afternoon, your mentor will usually select good problems of the right level for you. If you're learning on your own, it would be a little harder for you to select problems that challenge you at the right level, but a good starting point is a quality textbook. Good textbooks often come with good problems because good textbook authors understand the pedagogical principles I expounded earlier, that you learn best when you put the theory into practice. So they give you opportunities to do so. And if you are learning the subject from the textbook authors know what they've already taught you and what theory you should be exercising by that point. So they have at least some clue about the appropriate difficulty level for you, even though they don't actually know you personally. The textbook I adopted for my algorithms course is the most cited textbook in computer science, the famous Corman, Leiserson, Rivest, Stein Introduction to Algorithms that has sold over 1 million copies and of which a 4th edition came out earlier this year. It's a brilliant textbook and it's full of excellent exercises. I've interviewed its first author, Professor Corman, a few months ago, just before this new edition came out, and you might enjoy listening to the story of how he wrote the first draft of this book while he was still a PhD student. That book is a good source of well-calibrated programming problems. Another super famous computer science and programming textbook is The Art of Computer Programming, the life work of the legendary Donald Knuth, who got the Turing Award for it. It's on the difficult end of the spectrum of books to learn programming from, and not many people make it to the end, but Knuth put a lot of work into inventing the exercises and even rating each one individually for difficulty. But that's probably not the first resource I'd recommend for a self-learner. As I already said, the problems that are appropriate for you depend on your own individual level and experience. Once you already have some programming competence, the stuff you may want to learn is going to be not so much how to program this, how to program that, but rather how to solve real-world problems with your newfound ability to program. And you will find that from the algorithmic perspective, a majority of real-world problems are in fact not that challenging. But there are other difficulties that come from scalability and usability and compatibility and code base size and so on. So these too are things one needs to learn and which require practice and experience. It's generally the kind of experience you acquire on the job rather than through pedagogically crafted exercises or lectures at the university. And if you're getting towards that stage, I recommend moving up from solving textbook exercises to contributing to open source projects. At first, you might simply take a project that you're a user of and add a feature that you care about personally. If the developers, the gatekeepers of the open source project, accept your contribution and integrate it in the official code base, that's already a big step up in maturity compared to just solving textbook exercises on your own. Someone else has reviewed your code and found it good, worthy of inclusion. And if users of that open source project actually use your feature and comment on it and maybe even suggest further improvements or find bugs, that's also an important milestone. Now your code has users, it's not just you, and that's pretty important. Now if one day you ever go into business, maybe you start your own company like I did, you will find that the main way to make money is to address the pain points of your clients. The more useful you are to your clients, the more serious the problems you fix, and the more they'll be happy to pay you. So you should at some point graduate to solving problems that people actually have. And before you're ready to work with paying clients, contributing to open source projects can teach you a lot of what you need to know. The crucial differentiator is finally having users. Even if they're not paying you, they are your customers. And learning how to make your customers happy, if you're going to be successful in business eventually, is generally a much broader skill than those you acquire when studying programming and algorithms. And it is at least as important as learning how to solve the technical programming challenges. And this seems a good philosophical note on which to conclude today's video. Thanks very much for watching. Like, subscribe, and say suitcase in the comments if you want me to know that you made it all the way to the end. Do stuff that's useful to other people, and you will be rewarded handsomely for it.